Or let's see if we can do it without using our notes, but if you have to refer to your notes, then okay, all right? So we'll have them as a backup. So we've been discussing mammals. Yes. Could you please tell me, easiest question today, what are the 2 key characteristics that make a mammal a mammal? Another key characteristic that a mammal has, but it's not the defining ones, is that it has a delightful backbone. Could you please tell me what does that make us? Okay, characteristics such as endothermy. What is endothermy, please? What is our body temperature? We are higher order thinking, and it is to do with our brain. What makes us so intellectual? What is it that we see about our brain that says, you know what? We're higher order thinking because we've got lots of neural connections. One of the other things that we have to do is we have to consume food, right? What is energy? Okay. Now, if I only eat plants, what does that make me? The digestive system for a herbivore, you get a little hint. It's really long, really slow, and they chew a lot. And you said that it was to help break down the plant material. What specifically in that plant material needs that extra attention and maybe some extra bacteria? There are a whole bunch of mammals, right? The whole bunch of mammals, they are distinguished into 3 different categories based upon what? Could you tell me what is the difference between them? What is one method of reproduction that mammals might have? With a great word earlier, you said gestation. Could you please define it for me? Embryology. We discussed this in terms of both, we can look at it for the heart and the whole organism. Why? Why do we want to look at embryology? This is where I want to just tell you something really silly. All right? How do you prepare for class every day? And the best way to do it is to talk about what you did yesterday or today. Like go home today and tell someone. Now, I have parents tell me, you know, we had this delightful conversation at dinner the other night. My child was telling me all about X, Y, and Z. And well, they didn't particularly appreciate being told about X, Y, and Z because it wasn't dinner time conversation, because we're going to talk about some really weird things in here, from mucus to urine and poop and everything else in between. Sometimes not a dinner time conversation. Some parents, they like it. Like, well, that would be fine at my dinner time. But my husband, not so much. My suggestion is, if you've got a family member who would be willing to hear you tell about the day, talk to them, tell them what you know. And then when you get stumped, you're like, oh, wait, I know she talked about, look it up. It's going to really help solidify your information. Now, if you don't have a willing family member, find a dog. Don't try a cat, they walk away. Dogs you can kind of entice. But if you don't have a dog, a teddy bear. And if all else fails, I want you to pull out a spoon. I want you to talk to a spoon. Literally, just tell a spoon, what did you learn today? And you're going to hear me refer to your spoon. You need to talk to your spoon more, because that is me telling you this is the best way to review. Yes, I want you to review for my class, but tell the spoon your classes too. It doesn't mind, right? Pick up a spoon and talk to it and tell it what you learned today, so that you can identify areas where you're weak and that you can then go back in and fill in the details, okay? So tonight, we're going to talk about the hierarchy of life today. And tonight, I want you to go back, and if you don't have a family member or a dog that's willing to talk, tell your spoon about each of the levels of the hierarchy of life and explain it to your spoon or your listening audience, okay? And if you get stuck somewhere, look it up, fill in your details. And when I ask you tomorrow, or the next time I see you, you're going to be fabulously solid, okay? Try it and let me know what you think. And use a spoon rather than a fork. It's safer. We are going to talk about Anatomy and physiology. We're going to define those key words, and then we're going to talk about the hierarchy of life. So, are you ready? Flex those fingers. Let's go. Today's date, so make sure you date your notes. So, I've got a question for you. If you could define anatomy, you explain this one term. What is anatomy? So, anatomy, are you ready, ladies and gentlemen? I would define anatomy as the structure. So, if I were to talk about the heart, okay, if I were to talk about the heart, I would say that the heart has 4 chambers, there's lots of valves, it's made up of cardiac muscle, and I would explain about the structure of my heart. Now, physiology, hey Ben, could you please tell me, define for me, remember the one you gave me, physiology, could you tell me what that is?
It's the way your body functions.
Hey, look at that, it's a function, great job, high five. Function of the physiology, right? So this is how it works. The physiology is that it pumps the blood around the body. It gets from my nose to my toes and everywhere in between, right? So the function is the physiology. I want you to write some words down for me. Are you ready? Because this is a really key important statement. Anatomy dictates physiology. Okay? Anatomy dictates physiology. And I have that down here, or anatomy dictates function. So anatomy dictates physiology. All right. So I don't want you to get like, oh my gosh, there's words for board. I'm going to write them all down. No, I need you to stay with me. Okay. So I'm going to tell you a little story. Right now, my father, his anatomy of his heart is a little bit wonky. Right now, he has what is called aortic regurgitation. So there is a valve right here that goes from the bottom left side that pushes the blood up and out the aorta. And his valve does not close properly, okay? It is letting some blood that's meant to be going away and up to his brain and to the rest of his body. It lets some of it go back, so not the whole whack is going forward. As a result, his physiology, his function is, he gets really tired really easily. My dad struggles at the moment with exercise, with, any manual labor. He has to take frequent rests. So his anatomy has changed. And as a result, his physiology, his function has changed. So how does he fix this? Well, he needs to fix the anatomy, right? He needs to have a little surgery to go fix that valve, and then he'll be right as rain. Hooray, right? But I want you to keep these 3 words, anatomy dictates physiology, in your head, because you're going to see that throughout the course, okay? Throughout the course.
So for somebody who's out of shape, you would say if they exercised and got, I guess, more fit, would that be their anatomy changing, or would it just be like? Absolutely.
So the anatomy is the structure. So if my structure of my body, let's say I was in an obese body and I was an extra 200-300 pounds, right? My anatomy would change because I would have extra layers of adipose, lipids, fat tissue on me. And it would put a difference on the functionality of my joints, of my heart, of everything else in my body. And so the anatomy, the structure of me would then influence it. I have a statement up there that says the study of anatomy, structure, and physiology, the function, is ever developing. About, 2-3 years ago now, there was a membrane that goes over the surface of your intestine called the mesentery. And we used to think, and it was taught years ago, that it was just a tissue. But they've now found that it's actually an organ. And they found that there's lots of different parts to this organ. So it evolved even recently within the last couple of years. There are a number of reasons why we say that this science is continuing to evolve and change. Could you think of some of the reasons why? We're still evolving. We're still changing. Jonathan,
Technology is.
you are right. So if we think about the advent and the invention of X-rays, we now look at bones. Wow. But then we can look at CAT scans and MRIs and functional MRIs and PET scans and ultrasound. And as technology is getting better, we're getting a deeper understanding of us, which can then make us then have more evolutionary knowledge. But I'm going to say something else that we, as Avi said, are still evolving. Anybody in here lost their wisdom teeth? And I don't mean, oh, they fell out. You actually had to have them removed. Is it? Oh, very good. There's a few of us in here. Wisdom teeth are considered vestigial. So we used to use it, but now we don't. And they're still remaining in our body. So we can live without our wisdom teeth, no problem. But why is it that they're becoming vestigial? Well, we're evolving and our head is still changing. But because the shape of our head is changing, the shape of our jaw changes, and it actually loses the room. So these wisdom teeth, these are the last ones back here, these actually get, these actually get caught and they can get impacted, meaning they grow into the side of the bone. Very painful, very horrible. And so the dentist will come in and remove it for you, and it will make life significantly easier. But we used to use them because we used to use a whole lot of bark and cellulose, and we needed those. We needed those for when we had so much cellulose. I don't have so much anymore, so I'm kind of getting rid of it. Think about back, I don't know if anyone's been to Europe or not, but when I go to England, I'm always fascinated by these old houses, these old Tudor houses. You know why? Because their doors are my height. In fact, in some cases, I have to duck to go into castle doors or into old homes. Why? Do you see?
People were once shorter.
Yeah, we were so much shorter. All right, King Henry VIII. I know I'm pulling in some British history here, people, but King Henry VIII was about 6 foot, and he was thought of as a giant. He was massive in the eyes of his population. He was king and regal, and he was tall. He was massive. 6 foot? Kind of average for a man now, right? We get people that are 6'2", 6'3".
6'11".
6'11". You know, I would have been very tall. I'm 5'5". I'm not tall, right? I would have been really tall back then. Maybe burned as a witch because of being so tall. But, you know, there we are. All right. You came up with another one that you said was vestigial, and I like that. You said appendix. I want to amend that. Okay. Has anybody in here lost their appendix?
My dad has.
Yes, your dad and I are in the same boat. We're living just fine, right?
Yeah.
Yep, no problem. I don't have an appendix. My husband doesn't have an appendix. My mother doesn't have an appendix. This little tail right here, right? It was thought to be a structure that was remnants from when we were cavemen and ate just bark and roots and shoots and leaves and maybe a little woolly mammoth occasionally. But over time, it shrunk in form because we didn't use it and because of evolutionary adaptations. But what we know now is it's not a vestigial structure, but rather it's one that harbors our gut bacteria. And we need this bacteria inside our intestines to keep us really healthy. And we're going to go into great detail about that later because I'm fascinated by it. But if you have your dad or I, we have an upset stomach and you get an infection and, you know, it clears out, we would have a harder time recovering from it because we don't have our appendix, because your appendix is the reservoir for bacteria so that it can repopulate and recolonize the intestine. It's pretty cool. So you kind of want to keep your appendix if you can, but if it's going to rupture and explode, yeah, no. Time to go. Bye-bye. All right, one last one. Tailbone right here. This is the coccyx. And this is actually a fusion of multiple vertebrae that are put together. And yes, we used to have a tail that was attached to it, but no tails anymore. There is the occasional baby that is born with it, but it is usually amputated at birth. I kind of would like a tail. I think that'd be quite fun. but maybe my pants wouldn't fit so much. All right, did anybody take Greek or Latin in middle school? We used to teach it in the lower school. A lot of the scientific words stem from Latin. Now, here's my little bit of a, if anybody is absolutely assured that they're going to go into the medical field, or if you're really interested in this, they have a Latin course 1 and 2 on Florida Virtual School. Again, a free option that you can take. You can do it and teach you, basically self-taught online. But Latin, if you are, gung-ho about going into the medical field, I would highly recommend you take it. My daughter took it a couple of years ago, and she said it was actually really quite interesting and an enjoyable course. It wasn't too difficult. So if you want to learn more about that, please let me know and I'd be happy to tell you. All right, here we go. Oh, are you ready? We're going to switch and we're going to talk about the hierarchy of life. I've got an image for you to get into your brain and then we're going to talk. Are you ready? Boom. This is the hierarchy of life. So we've got an organism here, and we're going to go backwards. What basically do we boil down to?
Atoms.
Atoms and subatomic particles. Oh, golly gosh. There must be a few trillion of those in order to make us up, isn't it? Right? Okay, so instead of writing all of this, isn't that boring and horrible? We're going to do it on my e-glass. So, all right, so of these three subatomic particles, which one gives the identity of the atom? Protons, very good. So this one here, the number gives the identity to the atom, all right? Okay, so these are really, really, really essential and important, and we'll talk about them again in a minute. But what about calcium? Why do we need calcium?
Our bones.
Our bones. All right. What would be one of the things that we would get if we were low on calcium?
No.
Or we would need to drink some milk or anything that's got calcium base to it. But what is the health condition called? Anybody know? Have you ever heard of osteoporosis, brittle bone disorder, right? Or you may even have issues with your teeth because they're also part of this. We need calcium. So if you are lacking in that, you may get osteoporosis, which is porous, brittle bones. That wouldn't be a good thing, right? Okay. How about, did you know you also need calcium for your muscles? So you need to have calcium in order for your muscles to fire. And without that, it would be a problem. Okay. Same thing with magnesium. Magnesium is very good for your muscles, for your nerves. And we need to have the good balance of that. Another one that I'm going to put down here because somebody mentioned it is iron. What happens if you don't have enough iron? You can become cold, yes, it's one of the symptoms.
Can't really function like your body doesn't work.
It is so exhausting. It feels like you're walking through molasses. It is horrendous, depending upon the severity of it. Well, why? Because you need iron to be part of your blood product like hemoglobin to attach the oxygen to travel around your body. And if you don't have the oxygen, you get really tired and you get this condition called anemia. You become anemic, right? And that's low levels of iron. Oh. In England, we do not have Costco's. We have instead macros. Do you know why it's called macros? Because it's just like Costco's, but it's enormous, right? Macro means it is a large molecule. All right. There are 4 large molecules that I want to talk to you about. What are the 4 molecules, these macromolecules? And then finally, what do proteins do? So let's see. We said that these were enzymes. We said that they were for structure. We said that they were for energy. You can have These are going to be protein channels. They're there for transport. They're there for all sorts of things. So they're really, 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 really important. Okay. What is additional with the proteins? Nitrogen. That's the big thing that I need you to remember. Have you ever heard of the word a monomer? One. Mono means one. It's the building block, right? So what's the building block of a protein? Can you see it all okay?
Yeah.
Okay. It is the shape of this protein that is so important. What happens if the shape changes? If they're folded wrong, or if they change shape, they just don't function. Oh my goodness, oh my goodness, oh my goodness. Does anybody else's alarm bells go off in their heads and go, oh, look, isn't that just like Pierman said in the beginning of class, those 3 words? What was those 3 words that I said? If the shape changes, then the function changes. Oh, what was that? What was that? That's the shape. Makes the function. If the shape changes of this protein, the function don't what? Aye. There is a very, very important word. Hello, people. Very important word. We need to write this down. This is going to be key. Are you ready? What is the name for when a protein changes shape? If a protein changes shape, it no longer functions. Well, what will make it change shape? Anybody know what my triangle represents?
But change.
Change, right? This is delta. This is a symbol called delta, and we use it in math and science, and this means to change. Are you ready for story time? Does anybody ever fry an egg? I want you to imagine, right? Here we go. You got your egg. I want you to imagine you're going to go tap, tap, crack. Okay, I've just put the egg on the table here. Could you describe it to our friends, please? This is uncooked. This is raw egg. What does it look like? It's very liquidy. It's runny. It's movable. Okay, changes shape as I tilt the pan. Okay. Now I'm going to add some heat to it. The clear has gone solid white, and the yolk is still yellow, but it's hardened, right? The texture's changed. What is the main macromolecule in an egg? Protein. It changed shape. It changed color, changed texture. It denatured because of the heat. Ooh, right? Denatured because of the heat. What do you think would happen if I stuck that egg in a freezer? It would be the same as the egg was before I put it in the freezer. So what happens is it actually still, the cold denatures the protein. And there's actually a really cute little video that you can see, a cooking video, whereby somebody has put the eggs in the freezer, takes it out, peeled it, chops it up into slices, and then you get little mini fried eggs, like sliced, because every slice has, and it's really kind of cool. But when they take it out of the freezer, the white of the egg is no longer clear and translucent, you can't see through it. It is white. It has denatured the protein. Okay, well, that's eggs. What about us? Why do I need to make this? Has anybody ever burnt their fingers, like touch something hot when it got a burn? What happened to your fingies?
They turn like red. It's like flat.
Yeah, you get blister. Oh. I'm going to squirrel now. I've got a timeout. Here we go. We're going to decide. This is the mummy in me and the science in me. I've got to tell you. Got a question. You get blister, let's say from rubbing shoes, or you burnt your fingers. Should you pop it?
No.
Oh, thank goodness you said that. No. Why not?
Because it can be exposed to like bacterial and you can get infected.
Yeah, if it's not popped, don't pop it, because that pop, that the surface is there protecting the skin that's regrowing underneath, and the fluid that's inside is the protective mechanism. And if you pop it, you're removing that protection, and you're also opening it up for infection. Okay. Yeah. So if you got a burn, the skin changes color, and it falls off and doesn't work anymore, right? It did what? What happened to your skin?
It died
Why did it die?
because it doesn't have any oxygen in it.
Because the proteins were denatured.
Right there, that's what I wanted. The protein's denatured because your skin is made up of protein. Oh, I'll tell you a couple stories. When I was about 5 or 6, my dad and my mum took my sister and I skiing. And we were up in the French Alps somewhere. I have no idea where we were. Dad said, come on, we're going to do this great big run. It's going to be great. So we went up to the top of this mountain and we didn't know, but a storm came in. And the temperatures dropped dramatically. And the higher you are, the colder it is. And my sister and I, we were 6 and 8, we were both freezing. My mum got very, very cold. And we just wanted to sit there. We just didn't want to move because we were cold, we were grumpy. This was not fun. Why are we here? The mountains are white, right? My dad became like a drill sergeant. You're getting down this mountain, and forced us down. We just were so cold, just so cold. Our fingers, we could no longer feel. We couldn't feel our nose, we couldn't feel our toes. And my dad became more belligerent and more just get down this mountain. And when we got down the mountain, he apologized to us for being so mean and cruel because he was worried that we were going to get frostbite, because the temperatures got that cold that quickly. Now, what did we talk about when we talked about endothermic regulation, about blood to the extremities? It goes away, it retracts to the closest of your organs to keep them warm, right? You can lose a fingertip, but you can't lose a lung really easily, right? So the blood removed from our fingers, toes, and nose, and if we had stayed there too long, we would have got frostbite where the temperatures had got too cold, the blood had removed, and our proteins in our skin would have denatured, and we would have lost fingertips. Well, as you can see, I have all my fingertips, so thank you, Dad, for getting me down the mountain, right? Whew. All right. Do you want to hear another silly Pearman story? I'm going to tell you another silly Pearman story. All right. We said that temperature would denature the proteins. And we also said, well, JC very cleverly said that pH, a change in pH would. Has anybody ever had ceviche? What is ceviche?
It's when you take like raw fish
Yes.
and you cook it in like lemon juice.
But do you actually add heat?
No, just like the acid.
Hey, what's it doing?
Is it denaturing?
It denatures the protein by adding the acid from the lemon or the lime, and it cooks, but without heat, it cooks your fish, your raw fish, and you can eat it. If you're about to cook your fish of an evening, put a little bit of lemon juice on it, let it wait for 10 minutes or so before you put it in the oven. A, it will be tasty, and B, you can actually see a color change occur on the fish skin, or the fish's flesh, because the fillet of fish, because it's denaturing the protein. Oh, cool. Okay. Well, that's an acid. Base. Do you think it would do the same? Are you ready for my silly story? So when I went to college, I was put in this horrendous breeze block, horrible apartment building. And I was in the middle floor. And on the floor, we had probably 15 girls, 2 toilets, 1 shower. Oh, yes, it was horrendous. And we did have a cleaning lady, lovely lady. But the university, in their ultimate wisdom, would only allow her to use as strong as, what do you call it over here? Dishwashing soap, Dawn dish soap? Yeah, okay. So that's as much as strength she could use on cleaning. So when I got into the shower, I looked. It had black mold in it. It was moldy and it was gross and it stank and it was grim. So me and my ultimate wisdom, I went downtown and I bought myself a bucket. I bought myself a scrub brush. I bought rubber gloves because protection is key, and a bottle of bleach. And I came back and I put my Walkman in. Yes, I'm dating myself. I put my Walkman in and I got my music going and I started scrubbing and cleaning. Oh my gosh. People came from all over to look at our clean shower, and they were so impressed. Like, the cleaning lady brought the other cleaning ladies from the other floors to look at the shower. You could eat your dinner off. Oh, it was amazing. But here's the silly sausage part. I pulled off my rubber gloves and I went, oh, well, that's not good. And I looked on my forearms and I had huge blisters all the way down. It's like, how did I do that? Now, the logical sense of me was out the window because I'm like, oh my gosh. But when you think about it in reality, this is what happened. My bleach in the water, right? It was running down my gloves underneath and trapping on my skin. What happened? I evaporated the water in the bleach solution. So what happens when you take the water away from a solution like that? It concentrates it up, right? That's the word. I made it more concentrated. And so therefore, the bleach caused a huge chemical burn on my poor skin. What did it do to my skin? Oh, it denatured my proteins in my skin. Very good. And in the end, I had to go down to the clinic and they had to treat me for 2nd and 3rd degree burns. Oops. And they bandaged my arms up. And then I had to take a test the next day. And I couldn't actually write. So I had to do Frankenstein typing on my computer, one finger. It was funny. Not really. But my little tip to you as you go off to college is if you do decide to clean your showers, just make sure you do it safely. Goggles needed, and also don't use neat bleach, and make sure you're, sensible about it. Don't put on too much good music and keep getting carried away with the cleaning. All right. Okay, so we're talking about the hierarchy of life. Okay, so far in the hierarchy of life, we said subatomic particles, atoms, atoms to molecules, molecules to macromolecules. And then, so we said atoms to molecules to macromolecules. Okay. And then where does it go? Well, these macromolecules are predominantly protein, because remember, protein does everything. It goes into our organelles. Okay, here we go. Ladies and gentlemen, I know it's been a wee while since you have done biology, but when you did organelles, you would have listed off a whole bunch of them, and you would have listed off their function. Please dust off your notes and relook at them if you don't know what they do and that you don't remember. So please make sure that you are familiar with our organelles, okay? There is an amazing website online called Cells Alive. I have linked it and hyperlinked it on my bulletin board, but cellsalive.com is a great game that you can play that will allow you to go through and fully understand our organelles. So I'm going to put down a few of them, right? So we'll do nucleus. How about the nucleolus? Ribosomes. Golgi apparatus. Vesicles. Lysosomes. Mitochondria. That'll do for now. Okay, so remembering that, and if you don't know this and it's not coming back to you, please check out cellsalive.com. Remembering that the nucleus holds our genetic information, and inside the nucleus we have the nucleolus, which creates the ribosomes, and those ribosomes are really important because they create the protein. And then the Golgi apparatus and the vesicles. I like this one. It reminds me of a post office. So the proteins go and get sorted, they get modified, and then they get sent and delivered to where they're going by the vesicles. The lysosomes, these are my favorite. I don't know why, but I really appreciate the idea that there is something inside me doing some cleanup. So lysosomes do the cleanup inside your cell. They're the garbage men. And the mitochondria, let me hear it. What does the mitochondria do? How can we start? What does it produce, please? ATP. Which stands for? Adenosine triphosphate. Close. Adenosine. I love it. I love it. Well done. Well done. Okay. All right. So these organelles come together and they make a cell. Very good. Let's put a little asterisk here because remember, the cell is the basic unit of life. Now, we are a eukaryotic cell. or we are eukaryotic or eukaryotes, right? These are eukaryotic cells. Why, how do we know that they're eukaryotic?
They have one nucleus.
They have a nucleus, I like that. And more in general, they have membrane-bound organelles, right? That's what makes us a eukaryote. Now, there are different types of eukaryotic cells, like plants, animals, for example. We're not a plant because we don't photosynthesize, we don't have chloroplasts, we don't have a lower central vacuole, and we don't have a cell wall. So that's the reason why I'm not a plant. Although some days I feel a bit plant-like. Oh, I would like to be able to go in the sun and go, oh, full now. It would be so much easier. Less washing up. I would think, less having to think, what am I going to cook for dinner? Just stand outside. It'd be quite nice. Anyway, I digress. All right, I'm going to do some drawings, and I would like you to do some drawings. Obviously, if it's on my board here, it needs to go into your notes. So here we go. Are you ready? What do you notice about these that I've drawn? They're all cells, but what have you noticed? No real shape and rigid structure to it because there's no cell wall. I like that. But what do they notice? They're all different shapes, different sizes. All right, can anyone guess based upon my drawing, and I know that they are really suspicious of being actually drawings, but can anyone tell me what do you think these two are? I'm going to give you a hint. You have it, I don't. I have this, you have that. Sperm, very good, but we're talking about cells. So here we go. So this is a sperm cell, this is an egg cell. The sperm and the egg are significantly different in size. The sperm cell is really, really, really teeny tiny. The egg cell is actually really quite massive. It's one of the largest cells in the body. Anyone know what this is? A neuron is a brain cell, right? A nerve cell, neuron. This could be an erythrocyte, a red blood cell. I don't know. I may made that one up. And this one here, it could be anything really. It could be epithelial tissue, or it could be skin tissue. It could be tissue in my liver. All right. So what I wanted to know about cells is, and I'm going to write inside my egg just to save space, but obviously the egg does not have writing on it. What I wanted to know is that cells all have change in shape equals a change in function. Wow. Have we said this before?
Yeah.
When do we say this? Anatomy dictates
Physiology.
physiology. Very good. You can pat yourself on the back for that one. That was nice. Anatomy dictates physiology. So the anatomy, the shape, the structure is going to determine the function of it. All right, very good. We also need to know that they vary in size. And they vary in function and shape, and we talked about that. But they vary in the concentration. Oh, I really wanted to put in the concentration brackets. I'm going to underneath because that means concentration in chemistry, and we're gonna use that. All right, so they vary in concentration of organelles. Meaning that some cells have a greater concentration of one particular type of organelle over another. I'm going to give you an example. Are you ready? So in my heart, my muscles of my heart are constantly moving. So it needs a lot of energy. So which do you think of the organelles would be in higher concentration in my heart, in my cardiac muscle cells? Mitochondria, because I need the energy. Very good. All right, my liver. It does a lot of cleaning and detoxifying. Which cell of my liver do you think has a greater organelle concentration than, let's say, in my skin? Lysosomes, because they're the garbage men. Very good. Well done. Excellent. Okay. So these cells are going to come together. I'm going to redo up over here. I hope you won't mind. Okay. These cells come together to form a tissue, not the kind that you sneeze into, but a tissue is a collection of cells working together for one function. So these are cells working together for one function. These tissues, for example, epithelial tissue, cardiovascular tissue, to see what else, nervous tissue, vascular tissue, these different tissues, which we'll talk about again later, they come together to form an organ. And this is a group of tissues working together for one function. Oh my goodness. We're almost there, people. We're almost there. These organs come together to form
Organ system.
organ system. And you can imagine that it's a group of organs that are working together for one function. Now, I've got a question for you. How many organ systems are there? We're going to know that there are 11. And I like that. Okay, are you ready? I have a very silly acronym that I want you to remember. Are you ready? Run, Mr. Sliced. That's how we're going to remember it, people. All right, run, Mr. Sliced. Now, do you remember we did cellular respiration? I said, you need to know this. Guess what? This is what you need to know as well. So this and cellular respiration are the basis for this course. If you were to leave with nothing else other than cellular respiration and these 11 systems of the human body, I'd be happy, but I wouldn't be ecstatic. You're going to want a lot more than that, but you need to know this. So go home tonight and memorize this. So we've got the respiratory. Here we go. Do you know what these symbols mean?
Male, female.
Male and female. When I was about 8, I was horrified. I asked my mother, I was like, Mum, which one's which? And she was like, well, boys have pointy bits coming off them because they have a penis, and mummies love you and have their arms open and hug you. I was mortified by the first explanation. The second one kind of made up for it, but I was so horrified that I've never forgotten it since. So the one with the pointy bit on the end, that's you gentlemen, and the one with the plus sign, that's female, okay? All right, so these are the 11 systems of the human body. This is something that you are going to have to learn, okay? This is something you are going to have to learn. If I stand like this, does that make it easier for you for a second? Okay, so these 11 systems come together to form what?
Organ
Human body.
Organ
A
system.
human organism. Okay, ladies and gentlemen, hold up 1 second. You did a marvelous job today. I'm very, very proud of you. Please make sure we're on the same page.